So we're going to look at bearings. So here are the key facts that you need to know about bearings. So the first one is that north is 0. And notice we're writing it here with 3 zeros because the next fact is that all bearings, missed an S, must have 3 digits. So if you measure the angle and it's say 45 degrees, to write it as a bearing you need to put a 0 in front and make it 045 degrees. The other important rule that we need to know is that when we're measuring bearings, they're always measured clockwise from the north line. So typically on your diagram you're going to have a line that looks a bit like this that is labelled as the north line. Sometimes you might need to actually draw that on for yourself. So angles are measured clockwise from the north line, and we'll demonstrate that in a minute. Now, one last thing that I want to sort of warn you of before we get into these is that it's really important that you pay attention to what it says in the question, and particularly into where it says the bearing is from, because that is the north line. That's the north line that you need to use and work with, because sometimes there's more than one north line on a diagram. So let's have a look at some. So here we've got a little map-like thing. As you can see, we've got a north line over here to the side. Okay. Now, it does have some scale element questions in here as well, and that's quite common, but I'm not going to cover those parts in this video. So I'm ignoring this bit, and we're just going to look at this bit, which asks me to write down the bearing of Donhampton from Leek. Okay, so we need to draw our north line in at Leek, not Donhampton. So here we go, Leek is up here. So as carefully as you can, starting with the little cross that they've given us, you're going to draw a north line so it goes straight up parallel with the one that we've got there. So that's our north line drawn in. Now the next thing we need to do is draw a line that joins the Leek to the Donhampton places. So we're going to start and finish on the little crosses. Now, this is a bit more of a challenge for me than it would be for you, because obviously I'm using a big chunky pen, but there we go. All right, so there's Leek and Donhampton joined up. Now, we talked about the fact that in order to measure the bearing, we need to go clockwise from the north line. So that means the angle we're measuring is going from here to here. Okay, so we get our protractor in order to do this. In order to use your protractor, you need to make sure the little crosshairs that you'll find right here in the middle are right on top of the X. You then need to make sure that the line that goes along here is lined up with the north line. And then you need to make sure that you're reading the right scale, because there's numbers on the outside and on the inside. So if we remember that we always measure from 0 from the north line, then always use the one that starts at 0. So here it starts at 0 on the outside, so we're going to go round all the way round to here. And I know it might be a bit difficult for you to make out, but this is actually 130 degrees there. Okay, so let's look at some more examples. So here's the next one, and here it asks us to measure the bearing of B from A. So notice they've drawn 2 north lines in for us, nice and helpful, but which one are we using? We're going from A here, it says. So this is the one that we're interested in. So to measure the bearing of B from A, we're going to go clockwise from the north line, so that's the angle we need to measure. So we get ourselves lined up with the little cross in the middle and the line, and then we starting here at 0, so we go all the way round to here, and that looks to me to be about 74 degrees that we've got here. So there's a second part to this question. It says another house on a bearing of 170 from B. So there's another house to be drawn on here. The others were houses. So to work out where that house is, we're going to have to do two things. So first of all, we're going to need to know what direction it's in. So it says from B, so this time we're going to use this north line. So we're going to line ourselves up, and we've got to find 170 degrees. So that's nearly all the way around here. So I'm just going to put a little dot there. So that's the 170 degrees. Now this is where we need to do the scale bit to actually finish this off. So, well, actually, no, in this case, we're nice and easy. It says on the map, C is 5 centimeters from B. So we just need to take our ruler, line it up with B and the little dot we've just done. So we've got our 170 degree angle, and we need to make sure we come out 5 centimeters, which it almost was. It was just a little bit closer in than that. And Jude, they've asked us to put a cross on the spot and mark it as C. Okay, so watch out. It's always where from A we do the north line that's at A, from B we do the north line that's from B. So okay, right, so just wanted to demonstrate a couple more things. Now, the thing that I want to point out here is that this says diagram not drawn accurately. So we cannot use our protractor to solve this one. We're going to have to use angle facts to do this. Now, I've covered those facts in other videos, so I'm not going to go into them in detail here. Let's see what they ask. They ask us to work out the bearing of B from A. So that means the north line we're interested in is this one here that they've drawn in. And we've got to work out what the angle is that goes all the way round to this line. So how are we going to do that? Well, they've drawn a little dotted line in here and told us that that angle on that side is 50 degrees. So hopefully you can see that this part of the big angle that we want, this bit here, is 180 degrees. So if we add the 180 to this extra bit, we will find the bearing that we're interested in. So we want 180 plus 50, which is going to equal 230 degrees. So I'm showing you this because sometimes it's not a measuring, it's a working out. So look at the language. If it says work out, then you're going to have to do calculations instead. Okay.